So for this question here, we've got 1 plus 5 over x plus 6 over x squared is equal to 0. With all these quadratic equations in fractional form, we have to multiply both sides of the equation by the lowest common multiple. Now, the two things that are under the brackets, under the lines in this case, are x and x squared. Now, the lowest common multiple of x and x squared is the lowest term that they'll both divide evenly into. Now, in this case, if I have x, x will divide into x squared. It divides in x times. X squared divides into x squared. It divides in once. So the lowest common multiple for these two is simply x squared. Now, for the previous question, or the one we did a little while ago, you can always get a common multiple by multiplying everything underneath the fraction sign. You can always get the common multiple. But in some cases, it won't be the lowest common multiple. This case, it's better to multiply everything across by x squared. So if I have x squared, I'm going to multiply that whole side of that equation, and I'll multiply it by this side as well. We have 1 plus 5 over x plus 6 over x squared is equal to x squared times 0. Doing the same thing to both sides of the equation so it remains equal. So x squared by 1 is 1x squared. X squared by 5 over x plus x squared times 6 over x squared is equal to x squared times 0. Anything multiplied by 0 is simply 0. In this case, that cancels with that. X squared divides into x squared one time. X divided into x squared, you get x out. And you're left here with x squared plus 5x plus 6 is equal to 0. So in this case, brackets, brackets, x and x. You look for this sign here, the sign is the same, it's positive, and this sign is also positive. So we know the two signs in the brackets have to be plus and plus. 2 fractions that add to give 5 are 3 and 2. So either x plus 3 is equal to 0 or x plus 2 is equal to 0. For this one, subtract 3 from both sides and we get x is equal to minus 3. For this one, we'd subtract 2 from both sides and we get x is equal to minus 2. And that's the answer for that question.